empty plus k. Initially, battery is fully charged. The battery is fully charged. This means that when t is 0, which means initially, c equals 100. But when we substitute them there, you will have 100 equals m times 0 plus k, which will make k equals 100. So by this time, the equation is c equals mt plus 100. Questions on this?
No.
Then the next sentence was the battery life is 12.5 hours. What does it mean in terms of our equation?
We have to substitute with the t.
Okay, explain me what does all the sentence mean? At first 12.5 is for t, okay. When t equals 12.5, what happens? What does it mean that the battery life is 12.5 hours? After 12.5 hours, what happens?
The C becomes 0.
C is 0.
C is
Yes.
0.
Yeah.
So now we substitute these two into the last equation we found. So 0 equals m times 12.5 plus 100.
So that's how you find the value of m. Yeah.
So 12.5 m should equal negative 100, and m will be equal to negative 100 over 12.5, which is negative 8, I believe. Yeah, it is negative 8. Which means that the equation finally is c equals negative 8 plus 100. Negative 8t, sorry, plus 100. So from the initial thingy, we have that k equals 100. For the fact that the battery life is 12.5 hours, we use it to find m. And actually this minus 8 means that the battery loses 8% per hour. Right?
Yes.
Noms.
Can I switch to the presentation?
Yes.
Yeah.
Miss, can you share the presentation in Classroom?
Will it be not at the moment, at the end.
Yeah, I mean after everything is done, because it will be beneficial to move forward.
Yes, Miss, I agree that.
But I was planning to do it, but okay. But it is, by the way, it is long. Maybe we will finish it on Thursday. And determine a suitable domain for the function. This means to say suitable domain for the number of hours.
Yeah.
So what are the possible values for the number of hours in this situation? Because in general, if it was just a linear function, the linear functions have all the real numbers as a domain. But here we are talking about particular situation. What is the domain for Q?
It is between 0 and 12.5.
It is between 0 and 12.5 because more than 12.5 it will become negative percentage, which is
That cannot exist, yeah.
and the number of hours cannot be negative number. Okay. Next one, quadratic models. Quadratic model has the form of the quadratic function, of course, which is ax squared plus bx plus c. The graphs of these models have a turning point. We know this. We've studied it in IGCSE. So this type of model is frequently used when the situation being modeled has a maximum or a minimum value. And you have the two possible shapes. We've discussed them before. We are kind of familiar with this. So because the general form of the quadratic model is ax squared plus bx plus c, this means that you have three coefficients there, a, b, and c in general, which means that you will need three pieces of information to determine the a, b, and c. And using the coordinates of 3 points, you can form a system of three equations. For example, this one. You have a quadratic model that goes through the points 1, 9, 2, 18, and 331. This means that when you substitute the coordinates of each of the points into the original equation, you will get three equations for a, b, and c. So if it's set that it's quadratic model, which means that it looks like that, ax squared plus bx plus c. When you substitute x equals 1, y equals 9, you will get a plus b plus c equals 9. When you substitute x equals 2, y equals 18, you will get the second equation. And there is a mistake in the last one. It's when x equals 3, not 2, and y equals 31, you will get the third equation. Any questions on this substitution?
No, that's okay.
And then you put these three equations as simultaneous equations in your GDC as we practiced last week. And the GDC will tell you that a equals 2, b equals 3, c equals 4. Hence, the quadratic model from the beginning is 2x squared plus 3x plus 4 because we substitute a by 2, b by 3, and c by 4. Okay?
Just one question. Is it possible that we get multiple values of a and b and c? Like, you know...
When you solve linear equations, no.
Okay, what about quadratic models?
This is quadratic model, but the coefficients are...
Right. It's linear, yes. Okay.
The equations you get for the coefficients are linear, all of them. Any other questions? And the graph of a quadratic model, as we know, is called a parabola. It looks like that, or downwards, but the basic things stay the same. And there are several features of a parabola that you need to know. For a parabola, it has x-intercepts, not always, but in general they can have 0, 1, or 2 x-intercepts. They have y-intercept, they have a vertex, that is the turning point, and axis of symmetry, that is the line to which the graph is symmetric by itself. So, when the parabola has an equation of ax squared plus bx plus c, the axis of symmetry, this is a vertical line, so the equation is x equals a number. And the number is the first coordinate of the vertex, it's minus b over 2a. As it's stated in the next thing, the turning point of the parabola is called the vertex of the graph and has x coordinate minus b over 2a. Then the y-intercept is 0 and c, because always we find the y-intercept by substituting x by 0. And when you put 0 for x in the equation, you will have that y equals c. So the y-intercept is 0, c. The x-intercepts are the roots of the equation, quadratic equation ax squared plus bx plus c equals 0. And that's why it can have 0, 1, or 2 x-intercepts, because the quadratic equations usually have 0, 1, or 2 real roots. And the last thing is that the vertex is actually halfway between the x-intercepts. So if you have the x-intercepts, you are able to find the x-coordinate of the vertex. Questions by now? You can write down all these features.
Miss, I have a question.
Mm-hmm.
I think you told us before, but like, for the parabola, miss, when it's smiling, like in this equation, the value of a is positive, right?
Yeah.
Okay. When it's frowning, it's negative.
Yeah, it is that simple. When a is positive, it's smiley. When a is not positive, when it's negative, it's not smiley.
Yeah.
Any other questions?
No, miss.
So question 6.
No questions, miss.
Okay, question 6 we are doing.
We're gonna use x equals minus b divided by 2a.
Yes, so minus b divided by 2a equals 4.
Yes.
Yeah.
And is it all that we have to write?
Not all. You should use all the 3 given things in order to find something.
Okay.
So it is question 6. It is about quadratic model, which means that the function looks how? What's the general equation of the quadratic model?
It's ax squared plus bx plus c, miss, equals 0.
X not equals 0. This is the function. Equals 0 is the equation. Quadratic model means the function is the quadratic function. Y equals ax squared plus bx plus c. The other given things were axis of symmetry at x equals 4. Axis of symmetry at x equals 4. The next one is that the y-intercept is at 0, 12. Y-intercept at 0, 12. And the last thing given, the curve passes through 1, 5. Now let's see how we can use each of them. Somebody mentioned maybe Dilara or Nicoletta. The first one means what?
I mentioned it means that 4 equals b minus b divided by 2a.
So minus b divided by 2a equals 4. Can we simplify it a little bit?
I think yeah.
How?
If we move to a,
Okay, what will we get?
it's gonna be multiplication, so it's gonna be 8a.
So minus b equals 8a.
8a.
Okay, and in order to put it later into the calculator, how can we write? How have we to write it? Okay, we'll discuss it in a while. What does the second one mean? Y-intercepted 0, 12.
C is 12.
Yeah.
And C is 12, so C is 12. And which means that we can write the equation by now as y equals ax squared plus bx plus 12. And passes through 1 and 5, what does it mean?
It means x and y, so it's gonna be a and b. I think so.
Passes through the point 1 and 5 means that when x equals 1,
it means a is 1.
no, when x equals 1, y equals 5. When they've given you a point, they always talk about coordinates x and y of this point. So passing through 1 and 5 means that when x equals 1, y equals 5, which means that we will need to substitute 1 and 5 in the equation from the previous line.
5 equals a 1 to the power of 2. 1 squared actually, yeah. Plus 5x, yeah.
Oh, plus 1. B times 1, not 5x. This 1 and 5 are for A and B.
Okay.
No, are for X and Y, sorry, you mixed me up. So 5 equals A plus B plus 12.
Yes.
And for now, we have we found C, so we have this equation, and we have two relationships between A and B, this and this, and we solve them as simultaneous equations. But because I told you the calculator is your best friend, you can use it whenever you want. In order to solve these two equations simultaneously by the calculator, what do we need to do? No. How does your calculator want you to enter the equations? In which form?
Oh.
It's gonna be equal to 0.
We need to make them equal to 0 and simplify them. So we can write here minus 8a minus b equals 0. This one is done. The other one is a plus b plus 12 minus 5 equals 0, but we need also to calculate here 12 minus 5 before using the calculator. So putting them like that, we will have minus 8a minus b equals 0 and a plus b plus 7 equals 0. And then you use your calculator with linear equations with two variables. It can solve only linear, so you work it out with two equations. The coefficients for the first one will be minus 8 and minus 1 and 0. The coefficients for the second one will be positive 1, and positive 7.
Yes.
What did you get?
Anji.
Not Savarudu. I guess.
Sorry, that's my notification.
What did you get for A and B? Hello, somebody?
One second.
Should we say solve for A?
You solve the two equations simultaneously using your calculator as we did last week. Somebody with an answer?
Miss, is it 1 and minus 8?
Exactly. 1 and minus 8. Which will mean that the equation of this quadratic model is what? We got it till here. Now what is the final equation of the quadratic model?
So y equals 1x squared.
Which is just x squared.
Okay.
Mm-hmm.
Minus 8x plus 12.
So in this way, we only found the equation of the quadratic model, but they ask us these two purple things here to the left. To find the roots of f of x equals 0 and to find the minimum value the model takes. How will we find them?
For B, I think I have an idea. Assuming that this, I mean, we know that it's like a positive, the value of A is positive. We know it's like a smiling face. So for the smiling face, the vertex.
What is your best friend on math exam?
Calculator.
So, how do you find the roots of f of x equals 0 first? This is what we did yesterday. We found roots of polynomial.
Polynomial roots, yeah, using the calculator.
Yeah, so it is again polynomial, even when it's quadratic, it's polynomial.
Mm-hmm.
So you use your calculator to find the roots.
Mm-hmm.
What are the roots?
The roots are 2 and 6.
2 and 6. And again, find the minimum value the model takes. Can you use calculator to find it?
Yeah, sure.
Yeah, miss, we can graph it and see the minimum point.
Exactly.
But miss, we don't really need to point and graph it here because we know it. Wait, how do I use this?
Which one?
For the graph, miss, how do I type it? I don't understand.
You graph it and you go to the menu. There you have find intercept or find minimum. You should have.
Okay.
Did you find it?
Still trying.
Sorry.
I'm still trying to figure this calculator out. One second.
Okay, remind me on Thursday to show you how to do it.
Yeah, please. Thank you.
Calculator, but using calculator you will get that the coordinates of the vertex, the turning point are 4 and
-4. Yeah.
and -4. Which one is the answer for the question? Find the minimum value the model takes.
What does it mean by the minimum value the whole model takes, miss? When don't they want only one answer?
Yeah, that's what I'm asking. Which of the two numbers
Ah.
is the value of the model?
It's -4.
Yeah, it is the y
value, yeah.
coordinate. So the minimum value the model takes is -4. Questions?
No, miss, makes sense.
Logical, yeah.
Okay. Can I switch?
Yes.
Now try this one by yourself. I'm leaving the room for 5 minutes. I'll inform you when I'm back. Okay?
Okay.
going to be a random drunk girl that gets in. So this is a test. You better act right. It doesn't matter how drunk. Okay. Hi. Hola. Where we going? You say you got what? Oh, that's far. Man, you going far. Yeah. You not from around here? Alright, just buckle up. I got you. You know what I'm saying? I'm gonna keep you moving.
What's your name, fam? Elias. What? Blanco, yeah, it's Blanco. Your name's not Blanco, fam. It is. White. Blanco is white. It's Spanish. What type of reverse racism is this, fam?
I'm back. Anybody with an answer?
Да.
Da. The others?
I don't have the answers, but I know how to solve. I think so. But I still have some questions. I'm trying to find them. I'm working on it, miss.
So at first, when the axis of symmetry has equation x equals minus 3 over 2, and the graph intersects the x-axis at the point P 0 and the point Q, they want you first to state the coordinates of Q. What can we use? I'll go back to the features of the quadratic graph. Here we have it. Which of these things here, the features to the right, can we use to answer this question?
The vertex is halfway between the x-intercepts.
The vertex is halfway between the x-intercepts. If one of the intercepts is 2 and the axis is at minus 3 over 2, that is minus 1.5, what is the distance between 2 and minus 1.5?
3.5.
3.5. And we need to go 3.5 further to the left. So from minus 1.5, 3.5 to the left goes where?
Minus 5.
At minus 5. So the coordinates of Q are minus 5 and 0. Okay? Shall I write it?
Please.
Sure, miss.
Just a second. Okay. Axis of symmetry plus x equals negative 3/2, and one of the x-intercepts, one of the points is P, no, one of the x-intercepts. One of the x-intercepts at P 0. The other one, the other one. The vertex or the axis of symmetry is halfway between the x-intercepts, which means that actually the halfway between 2 points can be found when we find the average of these 2 points. So 2, which is the x-coordinate of P, plus the x-coordinate of Q, all this divided by 2 should equal negative 3/2. Because that's how we find midpoints between 2 points on the number line. We can ignore the denominator because it is the same. So 2 plus x-coordinate of Q should equal negative 3, which means that the x-coordinate of Q should equal negative 3 minus 2, or x-coordinate of Q should equal negative 5. So Q equals its x-intercept. We will write it as minus 5 and 0. Whoops. That. Is that okay? Questions on this?
No, I think so.
So then they tell you that y equals x squared plus b plus c. In this way, they actually tell you that a equals 1. And they want you to find b and c. The first thing we can use is that minus b over 2a equals minus b over 2. But from what they've given us, as I said, this means that a equals 1.
Ah, right, okay. Because they didn't put anything before x cubed.
Yeah. Which means that actually we have minus b over 2 equals minus 3/2. Ignoring the 2 and the minus because they are in both places, we will have that b equals 3. They've also told you that, but nothing. Okay, and we can use one of the x-intercepts, for example, 2, 0, because it lies on the graph of the function. P 2, 0 lies on the graph. From b equals 3, we will have that the equation is y equals x squared plus 3x plus c. And using the point 2, 0, we will have that 0 equals 2 squared plus 3 times 2 plus c. Or 0 equals 4 plus 6 plus c, and c equals -10. Finally, the equation is x squared plus 3x minus 10. And that's how you find b and c. And the last thing they want you to do is to sketch the graph of the function, labeling all axis intercepts.
-10 is the y-intercept.
-10 is the y-intercept. I will try to sketch it here. It won't be perfect, but okay. Actually, you can draw the graph on your calculator, or what they want you to do is to sketch the graph on the paper, just drawing it approximately and labeling it properly. So I know that I should have vertex at -1.2. I know that I have intercept at 2 at -5, at -5, and at -10. And at -10, that is like here. The vertex is at -1.2 and equals just a second, minus 12.25. So 10, 12.25, the vertex is somewhere here. And now it will be total mess with my drawing here, but something like that you should go like that. Excuse me for the ugly drawing. By hand you will do it better.
That's okay.
And we need to put the axis of symmetry also. That is kind of here. And we should label all these intercepts and
How did we find the turning point?
You can find it from your GDC. I just calculated it using the x coordinate of the vertex.
Okay, so we use GDC here.
Yeah, but remind me on Thursday to show you how to do it.
Yeah, okay.
And here it's -3/2. So you should put -5 on the first intercept, -2 on the second intercept, and -3/2 on the. Actually, you can put it here and write that it's x equals -3/2. What else we can do? Yeah, the 12 there. The -12 y-intercept. No, -10, sorry. Y-intercept. Here. That's in general what you're supposed to do for the last one. Any questions?
Nope.
So maybe we can be done for today. When you come on Thursday, we'll continue with this presentation, and after we finish it, I will upload it.
Okay, thank you, miss.
Okay, Miss.
Bye, Miss.
Okay,
Bye,
thank you.
Bye, miss. Have a nice day.